Welcome back guys, this is Shrikant. Today we are going to talk about table scan versus index scan or SIG. This is really very important and this is the basic step to start the performance tuning problem. Okay, now for this demonstration I'm going to use my existing database which basically we created in the part 2. The database name is test underscore april 08. Yeah, here we have a table, right? So let's see how many rows are there in this table. I loaded some data into this table, so you would find some more rows. You can use the same technique which I used in my last video to load the multiple rows. Now let's see how many rows are there. By looking at this, I would say this many rows, correct? Now let's take the max ID of the video also. Sorry, max ID from this table. So I can see, okay, this is a max ID, perfect. And how many rows are there? Actually here we have around this many rows, so just try to read it. It means that it's around 1.7 million, right? So okay, that's fine. Now for this demonstration I'm going to do what? I'm just going to show you a simple demonstration, just a simple query. Let's say where id is equal to, let's say, max value, for example. Okay, now see the actual see the estimated execution. I would see the table scan. Let's try to read it. So what is it saying me? It's saying me something like, estimated number of rows to be read is around 1.7 million. Okay, oh, that's wrong actually. I just need a single record, and why should I read this? Why should my system should read 1.7 million rows, right? Okay, now let's see the actual execution plan. So just on it and just run it. You would see the tab here. So if you just focus here, again it is showing you table scan, correct? And what is happening actually here inside? So it's saying me that it's showing me, see what is trying to say. It's trying to show me, let's try to zoom it. So if you focus here clearly, now you can see here actual number of rows. See, it's showing you 1.7 million, right? Okay, then you need to focus on actual number of rows for all execution. So basically it's showing me only one row is coming, but how many row it is processing? It is processing around 1.7 million rows, correct? Which basically doesn't make sense to me actually. And why it is happening? Because the table scan is happening. The table scan means entire table is basically getting scanned, right? So this table scan means entire table is getting scanned. That's the reason all the row inside this table are being used to get how many rows? Just a one row. So which basically doesn't make any sense to us, right? So this is performance wise, this is wrong. So what the solution, basically sometime your compiler or your SSS itself suggests you all those things, but I am not looking at any missing areas or anything. I'm just using my mind, right? Because I'm just learning things. So what I need to do, I need to create an index on this table. Then you need to know basically what are the different type of index. We will talk about that, but for this demonstration, as I know, id is basically the unique column, so I'm going to create a cluster index here. There are two type of index, cluster, non-cluster, and important these two, but there are sub important also. But in this demonstration I'm just telling you the cluster index is a kind of index. Basically only one index we can create on a table, and it basically sort the data in a physical order. That's the reason we can only have a one cluster index. And if you want to create a multiple indexes on the table, we need to go with a non-cluster index. But this demonstration is just to understand the table scan versus index scan 6, so I am focusing on only this demonstration. But in coming video we'll talk about the different type of index and how to create and how to deal with that. Okay, now I'm just creating a one cluster index on which column? ID column. So just give a proper name. Let's say I'm giving the name as a ix demo, and what is the column is id. On which table I want to create, I want to create it on demo, and on which column, this is the syntax. So just create it. Now I just created the index, that's fine. Now I'm going to select this query once again and just starting the actual execution plan and just run it. Now see, when I go to the execution plan, what would I see here? I would see here something very interesting thing called as instead of table scan. Previously it was a table scan. Now I'm seeing what index seek or scan I would see. But now in this video, now in this query, I'm only seeing index seek. Okay, that's fine. Let's take this parameter and just try to explore more in detail. Now again, if I just go here, okay, okay, I think that's fine. You can just ignore this because we know. Okay, that's fine. Now if you just try to understand in detail, now just focus on how actual execution, actual number of rows. So we can see actual number of rows is basically 1. Okay, estimated number of rows for all execution 1. Okay, estimated number of rows to be read, okay, 1. Estimate number of rows per action 1. Okay, now just focus here. Important thing is basically how many rows it is taking for the consideration to get the one row. It's taking only one row, right? So that's the reason index is very important. So in this demonstration I have shown you that how we can convert the table scan to the indexing scan. So then you may have a question, what's the difference between the index scan and seek, right? So index scan and seek is very important. uh, we will talk in the next video. So hope you understood how to tune the code if it is showing the table scan to the index seek, right? Instead of the cluster index you can also create the non-cluster index. It will also tune the code. Yeah, thanks for watching this video. If you really like our video, please comment over the comment section. It's not required you should subscribe our channel, at least you should comment. That will be helpful and that will motivate us to know that okay, you people are enjoying our video. Thanks for watching the video. Have a great day ahead.